Checking in. This is a video lecture for ANP2 lecture test 1, video number 7. So we're starting on page 17 of the note set, which starts with the word accommodation. I've mentioned this word before, and now you know how to spell it. You probably wanted to spell that too. And accommodation is the adjustment of the eye to give us clear vision. Let's see, I think we have a slide for that. There we go. So as a review by itself, the elastic fibers that surround the lens pull it spherically. But as we know, the lens is in the equator, if you will, the center, attached via ciliary zonules or lab term suspensory ligaments to the ciliary body. And we also know that the ciliary body is a wedge made mostly of ciliary muscle, and that the muscle is smooth muscle that can contract and relax. Now, when a circle of smooth muscle contracts, the diameter gets smaller. And when a circle of smooth muscle relaxes, the diameter gets bigger. Our muscles get shorter when they contract, and when a circular muscle contracts, the diameter of the circle gets smaller. So we're clear. Okay, so during positive accommodation, there we go, the lens becomes rounder to focus. Actually, I don't think we're ready for that part. The lens becomes rounder to focus on a nearby object. As we mentioned here, the rounder the lens, the shorter the focal distance. So during positive accommodation, the lens becomes rounder to focus on a nearby object. During negative accommodation, the lens becomes flatter to focus on a more distant object. When the ciliary muscle contracts, it pulls towards the lens, putting less tension on the ciliary zonule, which are the suspensory ligaments, allowing the lens to become less tension, elastic fibers, becomes rounder. So on the opposite tack, when the ciliary muscle relaxes, it pulls away from the lens, putting more tension on the ciliary zonules / suspensory ligaments, pulling the lens flatter. Okay, now the chart. Oops, I didn't make the chart. Oh, there it is. Chart. Okay, so again, positive accommodation, ciliary muscle contracts, making less tension on the ciliary zonules. Lens becomes rounder. This is for near vision. Negative accommodation, all the opposite. Ciliary muscle relaxes, creating more tension, pulling the lens flatter to see farther off. There we go. Next slide. Okay. So the image arrives at the retina, reverse left to right and upside down. And miniature. Okay. Because, okay, photon is a tiny packet of light energy. And the photons that we have are from light sources. And the primary light source on this planet is the sun. And then as the sunlight reaches the ground and things, it reflects off of them. We also have, electricity, so we have manufactured light sources like flashlights and lamps and oil lamps and, I don't know, lights. So all of these emit photons, which then bounce and scatter and reflect and refract off of everything. Okay. Darn it. There we go. So this item here, this white bar, acts as a complex light source because it's being bombarded by photons from all over, and those photons are reflecting and refracting off of this image. Well, reflecting. Unless it's clear, then it's going through, it's refracting, but anyway. And so the top part of the object acts as a light source, with the photons being bent by the cornea and the lens onto an inferior portion of the retina. This is exaggerated, the whole thing still be in the fovea, but and then from the bottom portion of this light source, because every object is a complex light source because photons bounce off the entire light source. And so they will be bent and focused because they're aimed up above. And so the bottom goes down, the top goes up, and that's why everything is upside down on your retina. And then in its next picture, you can see everything will be left and right. Here, the blue on the left goes to the right, the pink on the other side goes to this side, and everything is upside down, reversed left and right, and teensy. Okay. And then we will draw this. Does the rims draw this? No. Okay, let's whiteboard. Oh, W. Ah, I did it. Okay. So in the first drawing, we have a down arrow and then a retina for that complex object to reflect on. And I will change color to, I don't know, let's go with gray. So this will go down and that part will go up. So we will get an up arrow from this down arrow. And then we'll make the next one bigger. Okay, and again, changing colors. Ooh, cyan. Cyan was a good one. So we're going to be switched left to right. So this is what you draw in your circle retina circle. Okay, and the last one was the only one I could find with an up, down, left, right difference. And, ooh, what color are we going with? Pen color. Did we try the green? The green was that like neon. Not a fan of. Let's just do blue. Okay. That's a nice blue. There you go. So it will be crisscross applesauce, opposites, left, right, up, down. Okay. And boom. Nice. I'm off screen again, aren't I? Okay. So visual acuity is how well you see. 2020. Okay. So here's your E chart. And here's where we're testing at 20 feet away. So this is a 20-foot difference. The single quote is foot, double quote is inches. So this is a 20-foot difference. And if I put you, my patient, at the 20/20 line, and you see the same line of ease that normal visioned people see at 20 feet, then you are 20/20, you have normal vision because you see it 20 feet and I only have a 20-foot marker on the ground. So everybody gets tested at 20 feet. All these numbers start with 20 feet. Okay. So you see it 20 feet versus what normal people see at 20 feet. You know, I'm going to put quotes around this because this is what normal people, normal is not a thing. In medicine, it's within normal limits. There is a range of normal. There is not a normal. It's like the meme says, where the daughter asks the mama what's normal, and the mama says, it's just a setting on the dryer, honey. That's all it is. Okay. Now, what if you have 2015 vision? If I put you at the 20-foot line, because frankly, I only have one line on my floor, I put you at the 20-foot line, and you see at 20 feet what, oh, we're going to change color now. Going back to cyan. What normal visioned people see at 15 feet. So normal people have to get closer to it to see as well as you see it, then you have better than normal vision. So 2015 is better than normal vision. 2020 is normal, with quotes. Normal. I hate writing with a mouse. 2030 means you see, I need a new color. We haven't magentaed yet today. Ooh, magenta. You see at 20 feet what on screen normal visioned people see. Let's see, that's 10, 20, 30 feet. So this is less than normal, worse than normal, not normal. And 2200, have we done yellow? Say this is 200 feet, not to scale. 2200 is legally blind, and you can get a little money off on your taxes. Okay. So legally blind, you see clearly at 20 feet what a normal visioned person scoots back 10 times further to 200 feet to see. Floaters and scotomas. Scotomas are abnormal blind spots from compression of the optic nerve, damage to rods and cones, or damage to the visual pathways. Visual scotomas will often precede a migraine. Not all migraines get scotomas, but for many of us, that's the cue. Guess what you're in for? Yay. And floaters are blood cells or cellular debris in the vitreous body that drift across the field of vision. Because they're in the vitreous body, they move as you blink. That was page 17. Page 18, emmetropia. Change my other Noteset too. Emmetropia is normal vision. So this will be 2020 without an astigmatism. Myopia is nearsighted. Nearsighted means you can see things that are close up, but you cannot see things that are far away. So distant objects will be blurry. In myopia, the focal distance is in front of the retina. And so that's myopia, nearsightedness. If you have myopia, you will want distance glasses to drive. So like prescription sunglasses for during the day, or prescription not sunglasses for if you primarily drive at night. Hyperopia is farsightedness, where the focal point is posterior to behind the retina. And then it's easy to focus on things that are far away, but difficult to focus on things that are close. So if you have hyperopia or farsightedness, you will put on your glasses to read. If you are nearsighted, you will take off your glasses to read, generally speaking. And then presbyopia, is that on this picture? No. Presbyopia is an age-related farsightedness due to a loss of lens elasticity. So basically, once you hit 40, you're going to have the presbyopia, and you're going to need the readers, the glasses, which is especially weird if were nearsighted, because now you're both nearsighted and farsighted, and you get bifocals. And then the trifocals are, my sister, who's 6 years older than I am, says skip the bifocal trifocal crap and go straight for the lineless, the progressives, and my prescription's not quite strong enough to make sense of the of the progressives. I've tried them. I took them home and I kept taking them off to sea. So I've got another year or two between glasses until that prescription is strong enough for me to be able to actually see better with the glasses. If you can't see better with the glasses, it's not worth paying for them. Life wisdom with Dr. Jones. There you go. The wisdom you never asked for and will probably never need. How are lenses used to correct vision problems? Okay, so lenses in different shapes bend the light in different directions. So a concave lens is a divergent lens and lengthens the focal distance back to the retina. So for myopia, a diverging concave lens. I'm not seeing this yellow very well. Let's go back to magenta because magenta is always fun. And so hyperopia, farsightedness is a converging convex lens. So it will help bend the rays in to shorten the focal distance. And again, the goal with any of these lenses is to land the focal distance on the retina. So if it's too far ahead, move it back. If it's too far behind, move it up. There's a truism about dermatology. If it's wet, dry it. If it's dry, wet it. There's more to dermatology than that, but that's a joke, but kind of the basic concept. It's one of those it's funny because it's true things. Oh, look, an up close, bigger, more personal version of everything I just showed you in the tiny version. Surgical options for treatments of accommodation problems. Okay, that one's back here anyway. The book says photoreactive keratotic PRK. This word is on the list of words that I've read but never actually heard anyone say. So, and the laser shapes the cornea. We're more familiar with the LASIK, which is the laser assisted in situ keratomilia. Milius. Yeah, I've never heard anyone say that one either. And that's where the laser shapes the inner lining of the cornea. And this says that we will get about 70% normal vision with LASIK. It is the most common form of the surgery. You may still need reading glasses, and 10 years later, your prescription will still have changed. So it's not a lifelong fix, but it is like a 10-year fix. So there you go. It doesn't work for everyone, but 70% is quite a lot. So if that is in your budget and of interest to you, then go for it. And if not, that's fine too. Have we talked about informed consent yet? Oh, we haven't this semester. So the concept of informed consent is that people get to make choices about their own bodies. Gasp. But as a healthcare provider, it is your responsibility to give them the pros and the cons for the procedures beforehand. And that's it. Like, I'm going to tell you in this class, or I told you in 2401, or I'll tell you now, coloring your hair is not good for your hair. Okay. Do I care if you color your hair? No. Because you have informed consent. You've been informed that coloring your hair damages the protective cuticle layer. Bleaching your hair is really much worse than just coloring it, but you knew that. And it's your hair. That makes it your choice. Smoking is bad for your lungs. Smoking can, doesn't always, but can kill you. It's kind of a slow, drawn out form of suicide. But knowing that it's bad for you, if that's what you choose to spend your money on and it makes you feel better, then that's your choice to make. What's not your choice to make is smoking in front of kids, because secondhand smoke is actually worse for lungs than firsthand smoke, because if you're smoking normal cigarettes, you're smoking through a filter, and the people around you in your house and in your car aren't. So while I have no problem with you smoking, as long as you know that it's bad for you, you're making an informed consent choice. But you can't make that choice for other people around you. Now, if there were an adult around you and they say it's fine, then that's fine. But kids can't make those kinds of informed choices, assuming that you're one of their people. What they want is to be with you and to make you happy and to be in relationship with you. So you could ask your kid if it's okay to smoke around them, to smoke in the house, to smoke in the car, but they don't care about their health. They care about the health of their relationship with you. And since you are in power over them, they cannot say no. God love any kid that did. But generally speaking, it would take a very strong personality to be able to overcome all of that power disparity and give an honest answer. So while you can make informed consent decisions for yourself, you don't get to harm the health of your children. Now, you get to make informed consent healthcare choices for your children. That might hurt them, but there's a difference between hurt and harm. Having a tooth pulled will hurt, but it does not cause permanent damage to your child. It does not cause harm, assuming that the dentist doesn't give your kid permanent nerve damage, but that would be extreme and unusual. Making your kid brush their teeth does not hurt them or harm them. If you let your kid eat candy all day and never make them brush their teeth, then you're not hurting them, but you are causing them harm by causing long-term damage. And so, well, you have the right to make informed consent choices for yourself and for your child's health care. You don't get to make choices that harm them. Okay, moving on. Oh, we were talking about LASIK. Yeah, that's what we were talking about. So when we get to respiratory and cardiovascular and we talk about smoking again, you can tell me we already had this conversation. Although it's a summer session and I only have the one group that I'm teaching, so I might remember. When I have 7 sections that I'm lecturing to, I don't always remember who I've said what to. Because I'm bright, but I'm not remembering who I said what to with 7 different groups bright. True story. So photoreceptors are rods and cones, and also those IR piece. What were they? I'm curious. Come on. One more. Okay, 2 more. Poof. How far back was that? Thought I heard a dog. Seriously? IPRCG. IPRCG cells. And the rods and cones. I'm going to use the arrows on the keyboard because those work faster. Oh, it's still clicking. Okay. So the photoreceptors are the rods and the cones and the IPRCGs, and they detect photons. Photons are the basic unit of traveling light. That still cracks me up. Basic units of visible light. Radiant energy. Light is a radiant energy. Let me make sure I'm following the right Noteset. Photons, rods, and cones. Rods see photons. That's it. Light or not light. The cones, however, detect different wavelengths, and there are 3 different types of cones, and they detect 3 different patterns of wavelength, 3 different ranges of wavelengths. Yeah, ranges of wavelengths. And so the cones will identify different colors for you, the rods will not. The term rod and cone refers to the photoreceptor's outer segment. As you can see here, the cone-shaped one is on the cone, and the rod-shaped ones are on the rods. So that's why. And we already talked about the wavelength and the Roy G. Biv. Okay. Next slide then. All right. Still the next slide then. There we go. So visual pigments. Oh, magenta still. Yay. Are organic compounds in the disks of the outer segments that absorb photons. And visual purple, also called rhodopsin, is the main visual pigment, is made of the protein opsin bound to the pigment retinal, which is made from vitamin A. I forgot to turn a timer on again, didn't I? Did I really? I plugged my phone in. Yeah, no timer. Well, the last one I didn't put a timer on and got it like right at 30 minutes. So we start on page 17. I think we're going to do 18 and then call it a video because 19 starts like a whole shebang. Yeah, 19 is its own page. So we're going to finish page 18 of the note set and then finish this video. Okay, so we're already at the bottom of page 18. Yeah, that works. Okay, blue, green, and red cones. Red, green, and blue are the 3 different types of cones, and they respond differently to different wavelengths. So the basis for color vision is which pattern of rods and cones are activated. So if, like say, only red cones are activated, then you know you're looking at something red. If only blue cones and rods are activated, then you know you're looking at something blue or purple, depending. If we activate red and green, then we're somewhere in this range. And then let's see, where do we have all 3? There we go. We got blue, green, and this is the wavelength range where all 3 types of rods and cones are activated. So if all of your rods and cones are all activated at the same time, we interpret it as white, the color white, and black will be the absence of light. And is this where we talk about color blindness? Because I have the thing for color blindness. Nope, color blindness has been moved to page 20. And okay, so this here, the most common color blindness is red-green color blindness. So if you are red-green colorblind, then you will not see the number 12 in this circle of red and green dots. So, and we will talk more about color blindness next time. Let's see, we got through page 18. Let me write this on my post-it. Page 17 and 18 with some off-topic stuff, please. There are important things you need to know because y'all are college educated now. And that happens. Okay, so I'm going to move this tab to the beginning of page 19 where we talk about how you see at the biochemical level, and it's lots of fun. So, yeah, we're starting right here with the next video. It'll be legend. Wait for it. Terry. Neil Patrick Harris's quote. For the win. So this has been yet another video lecture. For A&P 2 lecture test 1, this one was video 7, I know because I wrote it down, and we covered pages 17 and 18 of the note set. My note set goes up through page 24, so we have another maybe two videos? Maybe two videos. And it's still kind of light outside, so I think I can get another video done tonight. Okay. Well, thank you as always for tuning in. The education must go on. Dr. J out as soon as I find the Control Alt Escape. No, not Control Alt Escape. Control Command Escape. Okay. So the Windows and then the Control and sorry. Thank you. Have a good one.